Welcome. Welcome to this hybrid electrical vehicle and a plug-in hybrid electrical vehicle tutorial offered by IEEE Vehicle Technology Society educational series. Now, as many of you know, the IEEE Vehicle Technology Society started as a wireless communication society. So over the years, vehicle electronics, especially in the past few years, hybrid electrical vehicles, plug-in hybrid electrical vehicles has evolved so much that we think it's very important for the society members to know this field, and also we want to attract the attention and engage interest of engineers working in this area. So here comes this class, this tutorial on plug-in hybrid electrical vehicles. Before I get into the actual tutorial contents, just give you a brief introduction of myself. My name is Chris Mee. I'm a senior member of IEEE. I am also an associate professor at the University of Michigan, Dearborn. Over the past 6 or 7 years, I've been teaching hybrid electrical vehicle class as a graduate class at our school, and I also have been offering this class for the Society of Automotive Engineers as a 3-day seminar, which has a very similar topic and similar contents. Now, in this class, of course, we'll talk about more plug-in hybrids. This seminar has been offered in 6 countries to different companies and different societies. So this 8-hour tutorial is going to be a condensed version of this hybrid electrical vehicle class. This next 8 hours, we're going to cover a lot of contents. We'll start with an introduction, and that will include also the fundamentals of HEV and PHUE. Following that, we're going to look at the mechanical coupling mechanism in hybrid electrical vehicles. That's very important because it involves more than 2 propulsion components, namely the engine and the electrical motor. How do you couple those 2 mechanical components to drive the vehicle? So that's the part we're going to cover. Following that, we're going to look at electrical drive components, namely we're going to look at electrical motors, power electronics, and batteries. Following the electrical components, we're going to put some focus on the electrical energy storage system for HEV and PHEV. We'll look at the battery management systems, the control of batteries, and so on. Following that, we're going to look at a number of other topics. For example, V2G, vehicle-to-grid communications, and vehicle-to-grid connections. How do you use your plug-in hybrid electrical vehicle as a backup power source for your home or office use? And then we'll look at a number of OEM PHUEs that is planned or is already on the marketplace, followed by looking at the aftermarket PHEV conversion by a few companies, and look at the conversion kits that you can use to convert a regular hybrid electrical vehicle to a plug-in hybrid electrical vehicle. So let's move ahead with our introduction. So in this part, we'll first review why and how we need this electrical and hybrid and plug-in hybrid electrical vehicles, which is mostly due to the energy and environmental concerns. Then we look at the architectures that is available to be used for different types of HEV and PHEV, and look at which one is suitable for use in plug-in HEV. And we'll look at how to evaluate a PHEV. You probably have heard about the driving range, the electrical driving range, and the equivalent miles per gallon, or MPG, and how do we calculate? and how do we evaluate that part of the performance of a plug-in electric vehicle? What are the applications of PHUE? Where do we use them? In passenger cars or trucks and some other areas. And then we'll look at, again, how to calculate the equivalent MPG and the equivalent electrical driving range if that HUE or that PHUE is blended PHUE. It's not a series or not a full PHUE. Now, over the years, we are facing two significant issues for the society. One of the important issues is energy demand. The other one is the environment. The energy demand is increasing in double digits in a percentage-wise. This is not only because the industrialized countries such as America, Canada, and many other countries, they are using steadily increased energy demand, and also that developing countries such as China and India, which have the most population, their energy demand also increases. With that energy demand increase, we are in an era that we need to look at how we can sustain this type of demand and sustain the economic development that needs to be maintained. So if you look at the word energy, the most energy would come from two sources, oil or petroleum, and the other one is coal. So those two take a big percentage in the total energy demand. Over the past number of years, we have been focusing on developing renewable energy and associated with also the nuclear energy development. But even though a lot of effort has been put through, but the percentage of energy developed for renewable energy still very small if you look at the total energy generated. So therefore, how do we reduce energy consumption is a big topic. Now you can look at many ways to reduce energy consumption. Hybrid and plug-in hybrid electric vehicle is one of them. So we're not saying that this is the only one, but this is one of the ways to reduce energy consumption. With all the energy that is available for us to use, by many studies, which we can conclude that petroleum will only support for the next 40 to 50 years. Coal may last a little longer, but eventually we're going to be out of this fossil fuel. So at that moment, we're going to have to switch to something else. Now it's going to be too late if we wait until that moment to switch. So we need to get ready. So that is why we need to look at all different kinds of renewable energy. In particular, in this tutorial, we look at why and how we can use plug-in hybrid electric vehicle and hybrid electric vehicle to reduce the total energy consumption. At the meantime, we also looking at environment concerns. Now, if you look at the total CO2 emission over the past 100 years, it has increased significantly in the past 100 years. In particular, it increased so much in the past 30 to 50 years. The reason is because increased energy consumption. Now, in the old days, basically the CO2 emission is balanced by consumption of plants and forests. But with the increased CO2 emission, with reducing the forest and plants, the CO2 is not, we're out of balance basically. So there's more CO2 goes to the atmosphere. When CO2 goes to the atmosphere, it forms a thick layer where it's going to trap the heat on the Earth instead of escaping or balancing the Earth. So when sunlight comes to the Earth, the heat will accumulate. And that will cause the Earth's temperature to change. In some areas, you will see temperature increase. In some other areas, you're going to see more extreme weathers. For example, you may see more tornadoes, and you may see more hurricanes, and you may see extended, drawn, hot, and maybe in a few areas you may see extremely cold days, and due to this environmental change caused by CO2 emissions. Now, this is real. This is not something that we are still schematic. Now, if you look at this, the CO2 emission and associated temperature rise in the past 100 years, it's been significant, and that also being observed in many areas. So, for example, you see more iceberg collapsing in the North Pole, and you see sea level rising in some areas, and you see many of the islands disappearing because of the rising sea level. So all these things altogether will cause deadly to the human society. So we need to look at this. We need to deal with the energy demand issue. We need to deal with the environmental issues. Now, how do we do that? Apparently, there are many things we need to do. There are many ways we can do. But on the transportation sector, that's one of the biggest oil demand. And that is also one of the biggest CO2 source. So we can work in this area to improve fuel economy, to reduce emissions so that we can meet that target sooner. We can meet our energy demand, reduce our energy demand, and reduce emissions. Now, this may not be the ultimate solution, but this is going to provide a partial solution, which ultimately is going to lead us to some methods of dealing with energy and environmental issues. So the nation, the United States and the world, other nations, they have all realized this and started working towards that goal. In the United States alone, the president has been calling for reform and calling for development, accelerated development in the transportation sector. In particular, he expected to have 1 million plug-in hybrid electric vehicles in the next 2 to 3 years. And that has to be done. In addition to that, there have been initiatives in the stimulus package to develop battery manufacturing and electric vehicle component manufacturing technology. And also there's a PHUE demonstration technology. Those two areas are totaling more than $10 billion for development and demonstration. This initiative not only will support new technology and a demonstration and a commercialization of PHUE, but it will also support create more jobs, which is going to ease the current economic downturn. Over the next 10 years, the goal is for the U.S. to reduce oil consumption so that the savings would equal to the amount of imported oil at this moment. So by working in some other areas, such as create more renewables, to develop 10% of the electricity from renewables by 2012 and 25% by 2025, the United States is going to eventually to be energy independent, not for the moment that we are energy dependent. So with all this energy and government initiatives, we are looking at a very bright future for HUE, PHUE, batteries, and our future to reduce energy consumption and emissions. Now, so if we look at the past a few years, even though we don't have OEM PHEVs available on the marketplace, but we did have a hybrid electric vehicle on the market for 10 years now. Started in the year 2000, where Prius and Honda introduced two HEVs in the United States, the Prius and the Honda Insight. Those two vehicles only sold but 9,000 in the year 2000. But it almost doubled every year until 2007. In 2007, we sold 324,000 hybrids. In 2008, the total HEV sales was down to 315,000. But that is partially due to the overall vehicle sales drop. Many of you probably know, in the United States, we normally sell 15 to 17 million vehicles per year. But in 2008, the sales was down close to 10 million vehicles. There's a significant reduction or decrease in vehicle sales. So that affected hybrid sales as well. Now in 2009, the sales number is not out yet, but by prediction, based on the sales happening in the early part of the year, we will probably see roughly the same number of vehicles sold in 2009. This chart shows the breakdown of hybrid electric vehicles sold in 2008. What you can see in 2008, there are more than 10 hybrid vehicle models available in the marketplace. However, most of the vehicles only sold a small number. This could be due to the unavailability from the manufacturer, also could be due to the unpopularity of the vehicle itself. Now, these numbers will tell us that if you look at the Prius, the Toyota Prius, that alone sold 158,000, which is about more than 50% of total HEV sales. Okay. By the way, this number is only the number for North American market. It does not include HEVs sold in Europe and Asia. And if you add all them together, this number actually would double, actually more than double. In the United States, as well as many other countries in the world, the government support new technologies, including hybrid electric vehicles. For example, the United States will give tax incentives to people who buy electric vehicles. The reason because you are saving energy and you are saving emissions. And the tax break is different on different model vehicles, and there's a limit of how many vehicles that will qualify for the tax break. What it means that if you buy this vehicle at the year end, when you report your tax, you're going to get this money back if you paid more than this amount of tax to the government. In addition to the tax credits, you can see that in 2008 model, there's still a number of vehicles that still qualify for tax break. In 2009 models, every hybrid qualifies for some tax break. In addition to this tax break, some local government also give some advantage to hybrid electric vehicle owners. For example, in California and Washington, D.C. area, if you drive a hybrid, you have the privilege to drive on high occupancy lane, HOA lane, where you can get to work faster. Some companies, like Google and some other companies, will give the employees some incentives if they buy a hybrid electric vehicle, because they believe you're going to spend more time at work other than spending your time in traffic. In some cities, they're providing hybrid electric vehicles with reduced parking rate or even free parking in some areas. Some cities have built charging stations for plug-in HEV, At the moment, some of the charging stations are free. Now, eventually, they're going to charge some money for charging your battery, but at the moment, it is an incentive, and the parking could be at reduced rate, and also reduce the charging rates. Okay, so far we basically covered some introductory information about plug-in and hybrid electrical vehicles. Now, so we get into the actual contents. What is a HEV and what is a PHEV? So HEV stands for hybrid electrical vehicle. So by its name, it got to be having some electrical components in the vehicle system. You can build different kinds of hybrid vehicle. For example, there have been hydraulic hybrid that use hydraulic as another propulsion in addition to the traditional gasoline or diesel propulsion systems. But in this class, we are more focusing on hybrid electric vehicle, which is HEV. So HEV would involve multiple source of propulsion systems. Most likely, you're going to see an electric motor with a gasoline engine or a diesel engine. So if you look at from this perspective, a traditional vehicle only has a conventional engine on board. A fuel cell vehicle, on the other hand, would have fuel cell and an electrical motor on board. And the fuel cell does not drive the vehicle, by the way, so the electrical motor does. And you also have batteries on board a fuel cell vehicle. So in that perspective, a fuel cell is a hybrid, and it is a series hybrid. Just like you have a series hybrid where you have an engine and a generator set. The onboard energy source can be gasoline or diesel. It doesn't have to be just the gasoline, it can be diesel as well. So you can build a diesel hybrid. A PHUE is a hybrid, but it is a plug-in hybrid. A plug-in means you can plug your vehicle into a power outlet and charge the battery on board. Therefore, you can drive your vehicle using the energy stored in the battery system on a vehicle. You can drive a certain distance at a certain speed. Depends on the type of vehicle, you may be able to drive using electrical only, or you may have to combine the electrical energy and onboard a gasoline engine to drive. But the goal is to displace fuel usage on the vehicle. So you're going to use less fuel but more electric. And the electrical energy is from your electrical outlet. It's either charged at home or you can charge at work. Based on how you arrange the components on board a HEV, you can have different types of HEV and PHEV. There are 4 basic types. The first type is the series HEV or series PHEV. In this configuration, you have electrical motor and you also have a gasoline engine and a generator. The gasoline engine and generator will generate electricity, and that electricity is provided to the electrical motor. The electrical motor is a component that is used to drive the vehicle. So that's a series type HEV. Another type is a parallel. In a parallel HEV, you will also have electrical motor and gasoline engine. But the difference is that in this arrangement, both the gasoline engine and the electrical motor can drive the vehicle. They can drive the vehicle at the same time or separately. So that's called parallel. But in a series hybrid, only the electrical motor is the driving component. The gasoline is not mechanically linked to the vehicle system. So you cannot use the gasoline to drive the vehicle in a series hybrid. Both series and parallel hybrid have advantage and a disadvantage. So if you want to combine these two vehicles, two kinds of configuration to make a vehicle that will take advantage of series and a parallel hybrid, you can make a series parallel hybrid. So in this configuration, you can either drive the vehicle in a series, or you can drive the vehicle in a parallel configuration. So apparently you're going to need 2 electrical motors on board in order to realize the 2 different functions. Other than series parallel, we also can configure the system so that you can have a complex hybrid, which is more complex than the series parallel hybrid. For example, you can use a 3rd electrical motor to drive the rear axle so that you can have a 4-wheel driving system, which is so-called electrical 4-wheel, or E4. So you can have that to realize more drivability, more functionality, and even more fuel economy in the vehicle system. Why do we need HUE and PHUE? Even though I mentioned in the beginning, it's more of environmental and energy demand driven, but in fact, the answer would be that these vehicles can overcome the disadvantage of conventional vehicles and pure electric vehicles. Overcoming their disadvantage will give you advantage, which ultimately is to reduce the fuel consumption and reduce emissions. So what is the issue with pure electric vehicle? One of the key questions that people ask is, why do we need hybrid? Why don't we directly go to electric vehicle so that we don't use gasoline at all, so we switch everything to electric? But the answer is that it's difficult because there are some drawbacks that we cannot overcome at the moment. For example, the very high initial cost of electrical vehicle make it very unrealistic to change every vehicle over to electric vehicle. Sometimes the cost could double the cost of a conventional vehicle. The second issue is the driving range. Because batteries still at this moment still are pretty large in size, so therefore you can only put limited amount of battery in a vehicle. With that limited number of batteries on board, the driving range of an electric vehicle would be limited. In the 90s, there have been a number of electric vehicles developed and sold in the marketplace, but most of the vehicles are having a range of 80 to 100 miles, which is not sufficient for most drivers. And they feel that we needed more range. We needed more than 100 miles. We want some range similar to, excuse me, we need a range similar to a conventional vehicle. A third drawback is the recharging of the batteries in an electric vehicle. It usually takes a long time. Takes 8 to 10 hours. So that's not acceptable to most people, because what happens if in the middle of the highway that you're out of battery? Traditionally, our vehicle can be filled in a few minutes in a gas station, and so many gas stations when you drive anywhere. But there's no such thing that you can swap your battery. At least at this moment, it's not possible. And lastly, of course, I already mentioned that the battery takes a lot of space. So otherwise, you will not have enough space for your cargo or passage. We look at the issues with conventional vehicles. They are mostly in these areas, the energy consumption and the high emissions, air pollution associated with ICE vehicles. So for example, if you look at a conventional vehicle, the gasoline engine is designed to operate at maybe 35 to 38% of efficiency, at peak efficiency. But the issue is not the engine itself. The engine is okay, they can be operated at a pretty good efficiency. But what happens is how we drive the vehicle. When we drive in cities, we are going to drive at low speed. So the engine is not going to operate at its peak efficiency. So efficiency now is maybe 20, 25%. And also, we brake and we stop at traffic lights and in a traffic situation. So therefore, the average efficiency of an engine in a conventional vehicle in city driving is fairly low. most of the time you're looking at less than 10%. So that is why the efficiency is so low in a conventional vehicle. Associated with the fuel economy is the emission. So emissions are pretty high. Now, even though you're at a traffic light, but you're still running the engine at idle. And you are consuming fuel, and you are emitting CO2 and other associated particles. I talked about CO2, I talked about the environment issues related to CO2 emissions, but in fact, in a vehicle system, there are also other emissions that are actually harmful to people's health, and they can cause lung diseases, for example, with some of the emissions. So they are not an issue that we can deal with conventional vehicle, even though we have been working hard to improve the efficiency, to improve the emissions. Many newer methods have been developed, many new technology have been developed, but still we cannot solve many of the issues because they are intrinsic to the vehicle, to the engine themselves. The advantage of a HUE is basically the disadvantage of a PHUE and a conventional vehicle. So it's a hybrid. It combines the advantage of the two systems and overcomes the disadvantage of the two systems. The first advantage, and the utmost important advantage, is a reduction in fuel consumption. We can increase fuel economy in HUE by optimizing the operating point of the engine in a HUE. Now we know that in conventional vehicle, the engine is designed to satisfy the driving demand of the vehicle, whether it's the speed of the vehicle or whether it's the power demand of the vehicle itself. But in a hybrid, because you have an electrical motor and a battery on board, so you basically can use the motor to assist the driving, or you can use the motor to subsidy the vehicle operation, to subsidy the engine operation. So therefore, you can somehow improve the operating efficiency of our engine in an HUE system. Secondly, you can stop the engine if you're sitting in the traffic or if you're at a traffic light. In fact, most of the hybrids these days will let you stop the engine when vehicle speed runs below certain miles per hour. For example, 25 miles per hour. Some of the vehicles will let you drive up to 39 miles per hour. Third is we can recover the kinetic energy in HUE systems. By recovering those energy, you can use energy for later driving. So therefore, you can save some fuel consumption. And lastly, is we can reduce the size of the engine in a vehicle system. Traditionally, the engines on a vehicle is designed to satisfy the acceleration. But in a hybrid, because we have electrical motor to assist the driving, therefore, we can reduce the size of the engine without impact the drivability of a vehicle system. By doing all these four things, we can significantly improve the fuel economy of HUE. Many of the vehicles' fuel economy are improved by at least 50 to 60%, which means you're going to reduce your fuel consumption by 50 to 60%. Secondly, we can reduce emissions. These are the same things that you do with the fuel economy improvement, because when you reduce the size of the engine, optimize the fuel consumption of the engine, and recover the kinetic energy and so on, and stop the engine at a traffic light, you are all reducing emissions. So once you reduce emissions, and you reduce fuel consumption. A third advantage is the quiet operation of a hybrid electric vehicle system. It's quiet because when you start the vehicle, the engine is normally off. Until you drive to a certain speed, the vehicle engine will start. So therefore, if you start out early in the morning you won't wake up anybody in the family because your vehicle is very quiet to get out of your garage. But of course, there have been some complaints from some associations. For example, the associations serving for the hearing people with hearing problems, because they wouldn't know that this vehicle coming if the vehicles are so quiet. So there are some issues that we have to deal with in this area. A last advantage that we can look at a hybrid vehicle is you can reduce the maintenance cost on the vehicle because you're using regenerative braking, so therefore there's less usage of the brake. Therefore, the brake repair is much less frequently. You probably won't need to replace your brake pads within the lifetime of the vehicle itself. And because optimized operation of the engine, so there's less need for oil change. There's less need for the exhaust repairs and so on. But of course, there are also issues related to hybrid vehicles. Otherwise, it would take no time for hybrid vehicle to become very popular. But even though it is popular now, but it's not as popular as we would expect. I mean, in the percentage, if you look at the percentage of hybrid sales, out of 300,000 vehicles, PHUE is sold, but there are more than 100 million vehicles sold in the U.S. There's only roughly 300,000 hybrids. So the percentage is still very small. The reasons are the related issues in hybrid electric vehicle system. We can look at 5 areas of the concerns of PHUE. One of them is the high initial cost. Even though it could be cheaper than an electrical vehicle, but it's not that cheaper. It cannot be cheaper than a conventional vehicle because you're involving more components such as battery, electrical motors, and control systems. Even though you use less batteries than electric EV, but you do have an engine on board. So in comparison to conventional vehicle, you have an electrical motor or 2 electrical motors, and you have batteries and control system. So therefore, it is generally more expensive. In some vehicles, depending on the type of vehicle you're looking at, some of those can be 20 to 30% more expensive. Some of the vehicles can be 50% more expensive than conventional vehicles. The second concern is a reliability concern because we're using more components in the vehicle system. So the reliability of those components could impact the vehicle systems. For example, if we look at the power electronics used in a vehicle system, and that's a relatively new application. In old days, well, not that old, maybe 10, 15 years, power electronics are used for stationary applications in a conditioned room. No vibration, there's no extremely hot or cold weathers to deal with. But on a vehicle system, you're looking at vibration and shock. You're looking at extremely high temperatures up to 65, 70 degree C. And you're looking at extremely cold weathers in some areas of the country, some areas in the world. You're looking at it down to minus 20 to 30, even 40 degree C. So that wide range of temperature and that kind of vibration and shock on the power electronic would be reliable? Would those electronics work the same way that they work in the stationary applications? So there is reliability concern. We're not saying that there is an issue, but people are worried. So convincing people that this system is as reliable as a conventional vehicle is critical because we are not into that many years, that many vehicles on the road yet. Okay? So it takes a little bit more time to get to the point that people would believe this vehicle is as reliable as the conventional vehicle that they buy and use. A third issue is related to warranty. Traditionally, some of the vehicles are warranted for certain number of years. With a hybrid, because the batteries usually last less than any other components on the vehicle system. So people are worried about what's going to happen if my batteries run out of energy and then cannot charge the batteries. Would you replace my battery? And how long that battery would last in my vehicle systems? Even though some of the vehicle manufacturers are offering 10 years warranty on the batteries, but apparently the batteries gets less energy available as time goes, so the vehicle fuel economy would drop as time goes by. Lastly, people are concerned by safety, because in a hybrid vehicle system, we're dealing with a voltage system that is at least 200 volts. Some vehicles run as high as 650 volts. And that voltage could be very dangerous if people don't know what they're doing with the vehicle system. So at this moment, hybrid vehicles can only serviced at authorized dealers. If you're not familiar with if you're not an electrical mechanical engineer or technician, you're not supposed to deal with the larger part of the vehicle systems. EMC stands for Electromagnetic Compatibility. Because the usage of power electronics and electrical motors in the system, we're dealing with high frequency switching, high power switching, and this electromagnetic field generated by the switching of high power, high voltage systems. Therefore, the other part of the vehicle systems, microcontrollers, sensors, actuators, they need to be protected from the electromagnetic interference. So those are the issues that we have to deal with in a hybrid electrical vehicle. Therefore, we can work towards the goal of making the vehicles more popular, make it cheaper, make it more affordable, make it more reliable, make it warranty work for the owners, and to deal with high voltage safety issues and deal with EMC issues. On top of plug-in, on top of hybrid electric vehicle, there's a plug-in HEV. A plug-in HEV, as I mentioned, is a vehicle that you can charge the battery on board. Once you charge the battery on board, the electrical energy is stored in the battery system. And then you can drive the vehicle using electrical energy other than the gasoline or diesel on board. With that electrical energy, you may be able to drive the vehicle for 20 to 40 miles. Now, let me explain why this 20 to 40 miles is important. There have been numerous of surveys done by different organizations. I'm going to show you in the next slide the survey done by EPRI, American Electrical Power Research Institute, American Power Research Institute. So what it shows that 75 of the American population drive 40 miles or less in their daily commuting. And about 60 to 70% actually drive 25 miles or less in their daily commuting. So what it suggests that if we build a plug-in HEV that has an electrical range of 20 to 40 miles, you can satisfy a large percentage of the population in their daily driving needs, which means they may not have to use gasoline at all in their daily commuting. So this is why it's important to develop a PHUE that can be driven for 20 to 40 miles. There are some concepts. If we design a PHUE that can be driven for 20 miles on electric, we call it PHUE 20. If that vehicle can be driven on electric for 40 miles, we call them a PHUE 40. Another reason that we want to build plug-in HEV is because our nation's grid, or any nation's power grid, have have electrical energy available during night times. There's usually high demand during the daytime, but in the later part of the evening, there's less demand on the power grid. So which is ideal to charge a plug-in HEV, because if you charge at night times, which means you're using the extra capacity available on the power grid. So there's no need for extra capacity on the power grid. The American Electrical Power Research Institute survey showed that if we have 1 million vehicles, we don't have to build any infrastructure we don't have to build any additional power plant in order to be able to charge that 1 million plug-in HEV. In fact, if we have 10 million hybrid on the road, we only need to build maybe 3 to 5 power plants. That's it. So we don't need so many infrastructure investment in order to satisfy the charging need for plug-in HEV. Now, that's the second reason. A third reason, if we look at it, electricity that we use to charge PHUE doesn't have to come from petroleum. Most likely, it's going to come from coal, nuclear, and renewables. I want to emphasize coal, nuclear, and renewable because we have a lot more coal reserves than oil. And many of the studies have shown that oil can only last for the next 40 to 50 years based on the consumption that we have today with energy demand increase and with the discovery of new oil reserves based on the past, say, 50 to 100 years, and you do you set up a model and you predict the usage and discovery and so on. It won't last for 40 to 50 years. But coal, on the other hand, will last for the next more than 200 to 400 years. So that's important that we shift some of the energy demand from oil to coal. That will help us, it will give us more time to develop alternative technologies. Nuclear, of course, is another great source of electrical energy. Now, of course, there's some different views on nuclear energy, but nuclear energy is vastly available. That's one reality. Renewables such as hydro, electric, wind, solar, and geothermal energy, those are endless, basically. So we can use a lot of renewables. At the present time, some of the renewable energies are still very expensive. Now, even though we have very popular hydroelectric generator stations, but developing renewable energy from solar and wind are still very expensive. So it will take time to realize all these renewable sources. But eventually, our PHUE can be charged from those sources. This chart, as I said before, is showing